Okay, so now we're on to the next page, which is solving the following using the exact values like we did with sine and cos, but this time, of course, we have got tan. Okay, so let's have a look. So the first thing that we can see here is the 2 inside of our x. So let's just change our domain as we do to find what our values are going to be. All right, so now we have that tan of something is going to be equal to -3. And if you look in your pages of values, let me see if I've got it. You could be flipping back. I think it's about 6C. Oh, here it is. Okay, so we're looking up when is tan -3. So hopefully you've all filled this out. So tan of -√3, is at 2 pi on 3. And you can go over further and find another value, that there's another value at 5 pi on 3. Okay, so from here we can say that tan of 2 pi on 3 is equal to -√3. And also, if we keep going, tan of 5 pi on 3 is equal to -√3. All right, so using that information, we've actually got 2x, remember? So we're going to go think about our quadrants first. We're going to say when is tan negative? So tan is negative in the second quadrant and the fourth quadrant. And we just go and use the same way we used to with sine and cos, but this time, so we're going to start with 2x. So 2x is equal to, so the first one that we're going to get to is 2 pi on 3, because that's somewhere over here. So 2 pi on 3, and we know from our table that it's right anyway. And the next one is 5 pi on 3, because that's going to be in our fourth quadrant. And then to calculate the next one, so we've gone around the circle once, we keep going all the way again. So we can do, this time we've got 2 pi plus 2 pi on 3, and 2 pi, you can go all the way around and do 2 pi plus 5 pi on 3, or of course you could do 4 pi minus if you wanted to. Okay, so from there we're going to get our x values. Well, first of all, we can, now these things should be really getting to be quite easy for you guys now when we're adding what we've got. So if we do that in thirds, we've got 6, so that becomes 8 pi on 3. And here we're going to have 6 plus 5 is 11 pi on 3. But the last step, of course, is to divide everything by 2. And so we get the value of x. So if we divide this by 2, we're going to end up with 2 pi on 6 and 5 pi on 6. Now this one's going to be 8 pi on 6. And of course we can halve both of those. So that will become 4 pi on 3. And then this one will become 11 pi on 6. Okay, that's how we do that question. Okay, so following on from this one, I'm not going to do all of this. We'll talk about what happens with it. But when you get down to the questions like this, you'll find the end when you have to add and subtract and divide and do lots of stuff to it, that it's going to take up a lot of your time. Okay, so yes, you do need to practice, and yes, you need to do this, but I'll just get you started for this one. All right, so if we were to have a look at what's happening here with our 2, this is when we want to actually change it so that we can manipulate our domain and what we have to use to actually find our values. So in this case, we're going to change that. So we're going to have to multiply that by 2. So that's going to become between -2 pi and +2 pi. So I needed to get all of this into the bracket so we could look up and work out where this is going to fall. Okay, now if you remember to go back to the chart that I just went to, I won't flip back for now, but everyone should be locating where it is, and you should get that tan of pi on 4 is equal to 1. Now, knowing that, this time we've got positive values of tan, so we're going to have something in the first quadrant and then something in the third quadrant that we're looking for. And be careful with where you're going to and from. So remember, you're at negative 2 pi going towards pi. So let's have a look at everything in this bracket. So we're going to have 2x plus 2 pi on 3 is equal to, and now we have to start building and see what we can come up with. So if we call this negative 2 pi and we go backwards, then this is going to be pi on 4 because we just found that out. And we want to find what our first position is going to be there. And so our first position, if we want to go here, is going to be less than 2 pi. So it's going to be negative 2 pi adding pi on 4. Okay, that's going to be our first one. The next one is going to be over here because we discussed how it's going to be in this third quadrant. So I'm going to put a comma, and then we're going to go from here. Now we're up to negative pi now. So this one is going to be, I'm going to run out of room, negative pi plus pi on 4. Okay, because we want to go, this time we're going to go all the way to there. All right, and now you should really be, now that I've run out of room, I'm just going to get rid of that because this part should be easy. We're now back to 0. So we're like at the start, so we want to go that far, so it's just pi on 4. And then the last distance that we want to go is here, so it's 4 pi on 4 plus 1, so it's 5 pi on 4. All right, now this is the part where you can take yourself away later or press pause because you have to put these together. All right, so say if we do the next step, so I'm not going to go through that with you. It's something that you should be practicing. You can, of course, ask us for help as to how we got there, but we're doing it over and over and over now, so hopefully you're getting better, as really it is just adding and subtracting of fractions. So from this line, you need to subtract 2 pi over 3 from each of these. Then when you've done that, you're going to divide by 2. Now I'm going to give you the answers to this, but as I said, I'm not going to show you all those steps. So if you don't get those answers, I can put the steps up for you at a later date, and you can check, or you can show me what you've done and check and I can check. But the answers that you should be getting are negative 29 pi over 24, minus 17 pi over 24, minus 5 pi over 12, and the last one is 7 pi over 24. Okay, so you can understand why I'm saying it's very timely to be doing all that working out. Okay, let's have a look at what is next. So I know myself and Mr. Hudson now have been talking about, don't forget, about tan and what that is equal to. All right, so let's have a think if you remember. So the first thing for these questions is the domain is 0 to 2 pi, but we're going to change it because of the 2. All right, so you should be looking at that now and knowing straight away that it's easier to change it at this point to get what your values are going to be. All right, so first thing I'm going to do is I'm going to divide both sides by -1. So at the beginning, you're going to manipulate what you've got, and you should be noticing that if you have this information that it might condense to a tan somewhere. Okay, so now I'm going to divide both sides by cos 2x. Now, you've done some of these when you've manipulated and they've ended up being tan, but you're going to have to start recognising what they look like. So on this side now we've got -1, and hopefully you can see on this side that we've got tan of 2x. Okay, now what value of tan is going to give you -1? And the answer is tan of pi on 4 will give you -1. You can go check your table if you need to. All right, so once again, we're looking at where tan is negative, and it's going to be in the second and the fourth. And this, of course, is pi on 4. This is pi on 4. Okay, now if we have a look back at our domain between 0 and 4 pi, and remembering that our x is not just plain x at the moment, it's 2x. So let's see what we get. So we're going to have 2x starting at domain 0. If we go to here, if this is pi on 4, then this is going to be 3 pi on 4. Okay, if we go all the way around here, so we've got, and I'm not even writing it now because I think these ones should be in your head. I'm really hoping if this is 2 pi and we subtract pi on 4, so if you're doing quarters, that's obviously 8 pi on 4 minus pi on 4 is 7 pi on 4. Okay, really hoping we've got that by now. If you go over to this section, all right, we are now at 3 pi, which is 12 pi on 4. Take away a pi on 4 because we're only going to here, so the next one's going to be 11 pi on 4. And our last one is pi on 4 less than 4 pi. So 4 pi will be 16 pi on 4. So our last one is 15 pi on 4. Now, if you haven't done any of the exercises or listened to any of the videos, none of that would make sense to you. But as I said, by now you should be so practiced in doing the basic ones that I'm hoping everybody's got that. All right, and the last thing we need to do for this question, of course, is we have x, but we have 2x and we want x, so we're going to divide it all by 2. So your answer is going to be 3 pi on 8 and 7 pi on 8 and 11 pi on 8 and 15 pi on 8. There you go. Now, make sure you check now that you're covering your basic domain, okay, which is what this is. So 15 pi on 8 is just short of 2 pi, which is perfect. All right, so we use this information, don't forget, to start, and then so that it all comes out perfectly to be in the correct domain. Excellent. All right, so we're going to use the information about sine x over cos x is equal to tan x once more. All right, so we are this one. Think about what you can do. So we're going to divide both sides by cos of x, and we will have root 3 is equal to tan of x. So this one is a straightforward one. If you look up your graph or you know it already, your table, you should find out there that x is equal to pi on 3. So in other words, tan of pi on 3 is equal to root x. All right, from there, we want positives. So we're in first quadrant and third quadrant. We've just said this is pi on 3, this is pi on 3. Just plain x, which is wonderful. So we're going to go from 0 to 2 pi. So we're going to go up there. So our first one is just pi on 3. And our second one is going to be 4 pi on 3. Okay, so obviously that was easy. Once you got to this stage, it's just recognising how to manipulate what you've got to end up being sine x over cos x is equal to tan x. All right, so the last one we have to do for this exercise is sketching and then finding coordinates. So you will see here, I'm sorry about my shadow there, but I should be okay for what I need to do. Okay. So the first thing we're going to do is draw what we have. And the question says between negative pi and pi. So I have pi on 2, negative pi on 2, negative pi. And we need to have a look at what the period is. So we're going to have period, remembering that our period for sine and cos is 2 pi on n. So it's 2 pi on 2. So our period, even though we have been doing tan, is back to a period of pi for sine and cos. Okay, so let's put these in. If we have a look at our first one, so we're going to have a look at cos of 2x. We've worked out, we've used the 2. So apart from that, we just have a normal cos graph with a period of pi. So I'm going to start at 1. We're going to come halfway through that, down to pi on 2 at -1, up and ending up at pi 1, and then obviously do the same on the other side. Ugh, not looking very nice. Mr. Hudson's so good at drawing these. I'm so not. Hopefully you are better than me, but we can also see what I'm supposed to be doing. All right, so this is our first one. I'm going to put cos 2x up there so I don't get confused by what I'm doing. All right, the next one is negative sine of 2x. So we still want to go within pi is our domain, and our normal sine graph would start here and go up here, but we want the negative of that. So we're going to go opposite. Now by now, we should be good at knowing what that is supposed to look like. Hopefully yours is better than mine. Okay, and then on the other side, we're doing inverse of what our sine normally looks like. All right, so we get the gist, hopefully. And just put a label on it so when you come back later, if you need to know, you can see what it is. Excellent. Now, you have therefore sketched on the same axes so far. The next part is find the coordinates of the intersection. All right, so let's work out what we mean by that first of all. So the intersection obviously is where the two graphs meet. So how many of them are you going to have? So looking at your diagram, not waiting for me, have a look. Okay, so you should get that you want 1 intersection, 2, 3, and 4. Now, when we do intersections, if it was a normal linear equation, then we would make one equal the other, and that's what we need to do in this case. But you can, because you can see here, it's not going to be something simple and straightforward that's already in our graph. So we're going to make one of these, one equation equal the other, and I'm just going to use a bigger piece of paper because I just want more space. Okay, so let's do this. All right, so we are going to say cos of, oh, my paper's going everywhere, 2x is equal to negative sine of 2x. Okay, but from fiddling round with our tan information, that's why you know this is now a tan question from before, and why it's in here, we know that tan of 2x equals -1. Okay, so we have divided both sides, and then we will end up with that answer. Now, we also know that tan of pi on 4 is equal to -1. So what do we do with that information? If you think again about your circle, or where this information is going to be played out, we have negative in second and fourth, and we have pi on 4. And pi on 4. Okay, so what information, how can we use this information? We are going to think about where the domain is as well. So the domain in this case is going to be negative 2 pi for working out 2 pi. Okay, if you go back to the question, you have domain of 0 to pi here, but remember we changed. Oh, that's the wrong question, but the same information. So negative, no it's not, negative pi to pi, sorry, and in front of the x is a 2, so we're going to use negative 2 pi and 2 pi. All right, so let's see. We're going to have tan of 2x because that's what we're using now is equal to, so if we start here at negative 2 pi, we want to go all the way to here. That's going to be our first one. So our first one is going to be negative 2 pi plus, now, oh, that's in the wrong spot. This should be pi on 4. Sorry. Plus, so all of this must be 3 pi on 4. So that can be our first one that we've got. And then we're going to go round, and then we're going to hit here. Now, the easiest way, don't forget, because this is also 0, is to come just back here, and that would be 0 minus pi on 4. Or most of you will probably just say, oh, that's negative pi on 4. Now, if we keep going around to the next part, so now we're getting a bit messy on my diagram. We're still going, so we go from here to here. This is 0 now, so we get up there, and it must be 3 pi on 4. And then if we go all the way around to the fourth quadrant, the last one that you're hopefully getting is going to be 7 pi on 4. All right, which was the same as what you've been doing, 2 pi minus pi on 4. Okay, so now we want to get x. Oh, let's just make these a bit prettier. So minus 2 pi is minus 8 pi on 4 plus 3 pi. Okay, so that's minus 5 pi on 4. This one is negative pi on 4, 3 pi on 4, and 7 pi on 4. Okay, now we have to divide everything by 2 to get x. So our x values are minus 5 pi on 8, minus pi on 8, 3 pi on 8, and 7 pi on 8. Now, what you want to do is go and have a look at your graph now and see if these actually make sense. Do they look like they can be where your graph is? So I'm going to put my graph back onto the screen, and I'm going to explain what I mean. So the first one that I have here, the first x value that I have is negative 5 pi on 8. So if we come here and imagine what does that look like? Negative 5 pi on 8. Okay, which is a little bit less than negative pi on 2. It's about here. Yep, that looks reasonable. Okay, and the next one that you've got for your value is negative pi on 8. Okay, which is going to be here. Negative pi on 8. Okay, yep, that looks okay. It's about a quarter of the way from pi on 2, which is good. The next one we've got is 3 pi on 8. which looks very reasonable as to our next intersection. And then our last one over here, we think could be 7 pi on 8. And that looks good too. Excellent. All right, so we've got our x values. That's fine, but we actually need to get our y values. So what is this point here? And the thing is, in methods, you know, so you want to plug all these values in. It's just like an xy graph. So now you want to plug all of these in to get into one of the equations so that you get these values. But you should know, and look, I'm sorry, mine's not accurate there, that these, once you get one of these, then, and you're confident with what you've got, then it's just reflected. So these two should be the same positive value, and these will be the same negative of the whatever you get. So let's have a look and see what I'm talking about. So first we're going to try, okay, so we've got y equals cos 2x. That's one of our equations. We only need to use one, remember. So let's try an easy point. Okay, so maybe let's try negative pi on 8. Okay, so when x equals negative pi on 8, we're going to sub that in. Y equals cos 2 times negative pi on 8, which equals cos of negative pi on 4, which equals root 2 on 2. So from that working out, I'm claiming that negative pi on 8 root 2 on 2 is the coordinate, that one of our coordinates that we want. So let's go back and have a look at the graph at negative pi on 8. Could that be root 2 on 2? Yes, in fact, it could. So we're going to fill that in here, root 2 on 2. Now, from there, you should therefore be able to say another point. Okay, and another point will be, therefore, 7 pi on 8. 7 pi on 8 root 2 on 2 is another coordinate. And then going down the bottom, from here you can build other ones. So this should be, or is, negative root 2 on 2. So we will also have where's our negatives? Negative 5 pi on 8 negative root 2 on 2. And our last one over here is going to be 3 pi on 8 negative root 2 on 2. Oh gosh, I'm really sorry about the shading tonight, everybody. Okay, so these are now our 4 values. You should, if you want practice, go sub all these in and make sure they work. But know that in an exam, you should be able to do one, transcribe it to your graph, make sure it looks like it could work. And then you should be able to just write these with the confidence knowing this information, all right, that they are going to be the same. All right, that's 6J. Thanks, everybody.